everybody to CS Kaksha, and today's question is minimum number of refueling stops, and this is a classic greedy plus heap problem. It's asked in many interviews across the place. So we will be going through the question and we will be trying to understand what the question is expecting and what are the hints and information that the question is giving, and let's dissect that. So a car travels from a starting position to a destination which is target miles east of the starting position. Alright, so we've got a starting position. We'll just write this. We've got a starting position over here and we've got a target over here. Alright, so this is what we've understood now. So there are gas stations along the way. The gas stations are represented by an array stations, where station I is basically positions I, fuel I. So this basically is indicating a pair or a vector of vector or a vector of pairs. So we will realize from the question input that it's vector of vector. So we can say that a station I is basically having two elements within that. First one will be indicating the position, and the second would be indicating the fuel. So indicates the ith gas station is position I miles east of the starting position and has fuel I liters of gas. We will understand this line when I'm explaining. So this car starts with an infinite tank of gas. So it's not infinite gas, because if it was infinite gas the problem would not have been placed. We have enough amount of storage for a lot of gas. Gas basically means petrol for people in India, which initially has start fuel liters of fuel in it. It uses 1 liter of gas per 1 mile that it drives. So this is the conversion that we are having. 1 liter of gas per 1 mile that it drives. So when the car reaches a gas station, it may stop and refuel, transferring all the gas from the stations into the car. It's not necessary that, so it can also be partial, it can be also all the gas. So return the minimum number of refueling stops that the car must make in order to reach its destination. And if it cannot reach the destination, return -1. I believe this is a very practical problem in our life. For example, if we want to go to point A to point B and we have some certain level of petrol within our vehicle, so we know that this particular vehicle can only take us to a distance that might not be sufficient to reach the target destination, and we'll have to stop it somewhere and refuel it. If not, we will not be able to reach it, and then we'll have to push the car. So this situation, I'm pretty sure, might have arisen at some point of your life. So this particular question is encompassing that particular situation. So now if the duration is big, so from this problem we have to calculate and optimize the minimum number of stops. So for example, let's take this problem over here. So okay, we'll just go one by one. So we've got target 1 and we've got the start fuel 1, and we've got no stations altogether. Since we have start fuel as 1 and we also have to reach only basically 1 mile, so the start fuel is sufficient to reach the target. And since the start fuel is sufficient to reach the target, the output is 0. As you can see here, we can reach the target without refueling. And now if you see, the target is 100 and we have the start fuel as 1. So since the start fuel is at 1, so we can only go 1 mile east, but the nearest station is at 10 miles, so we'll not be able to reach the nearest station at all. So hence we'll have to return -1 because we cannot reach the target or even the first gas station. So now coming to this problem, target 100, right? Station's fuel. So I will just use this particular example over here. So we've got a fuel, let's say we've got a target fuel, we've got to reach 100 miles, and we've got a target fuel of 10, right? We've got a target fuel of 10 over here, and we've got a station at 10 miles, 10 position, 10 miles, and it can give us 60 liters of fuel, and 1 liter can help us, and the conversion over here is 1 liter equals 1 mile. Okay, so this is the So this is the conversion. So 1 liter will give us 1 mile. So over here we can see, so one station is located over here, and then we've got another at 20, 30 and 30, 30. So at 20 miles we've got one which can give us 20 miles, we've got one which will give us 20 liters of fuel. We've got at 30 miles as well, which will give us 30 liters of fuel. And then we've also got, we've also got one at 60, 40, we've got that as well. So we've got one station as well which is at 60 mile, which will give us 40 liters of fuel. Miles for India it's kilometers, but since the question is in miles, I'm just going along with that. So as you can see over here, definitely if I add all these up, 60 plus 20, 80, 80 plus 30, 110, 110 plus 40, 150, it is more than sufficient to reach 100 miles, right? Because I've got 150 liters of fuel, and since 1 liter of fuel is equal to 1 mile, so with the help of that, I'm in a position. So if I stop at all the places, if I stop at all the stations, I can cover more than 100 miles and I can cover 150 miles. I can do that, right? But the question over here is, what is the minimum number of stops that I need to make to reach this target destination, which is 100 miles. I need to reach this target destination, which is 100 miles, and I also have a starting fuel as well, which is of 10 liters, which will enable me to go to the first station. If it was anything less than 10, if it was 9 liters of start fuel, I'll only be able to reach over here, and I will not be able to make it to the first station, and I will have to return -1, which is stating that I cannot complete this journey at all, right? So there is just one approach to solve it, and the one approach is the greedy approach, which will basically plan all the destinations, all the stations, and will pick the maximum fuel that is present. So what I will do, see, so I've got 10 liters of fuel here, right? So once I reach here, I'll only able to reach one station over here, which is this particular station. If I cannot reach to at this station because it requires 20 liters of fuel, right? Because it is at 20 miles. I'll not be able to reach this. So since I'll be only able to reach one particular station over here, I'll just use this up. And once I have 60 liters of fuel with me, I'll be able to go over here as well. I'll be able to go here as well. Once I have here, so I have a choice to make. I'll either go over here or I can either go over here, right? And I can also go over here because I have 60 liters, right? So over here, once I reach over here, I'm at 10 miles already here. I've already reached here, and now I have 60 liters of fuel with me. So what I can do is I'll go here 20, 30, and this is at 60 miles, right? I can also go over here. So I have a location. I have a choice to make as to which station I have to stop. So with the help, what greedy solution says is that the local solution, local optimal, when I add all the local optimal, I will get the global optimal, global solution, optimized solution, globally optimized solution. So that is what we are going to do. So we will see that with the current fuel, with the existing fuel, how much I can push and what are the stations I can go. And within the stations that I can go, I will try to take the maximum fuel that is possible. So with 10 liters, I can only go to the first station, hence I will take that fuel. And from 60 liters, I can go to the rest of the fuels. I can go to 20 liters, I can also go to the 30 liters one, I can also go to the 40 liters one, that is at 60 miles. So I will take this particular fuel over here at 40 liters, and once I have this, I will be reaching the destination also, because after this, once I'm in this station, I only require the destination is 100, right? So I'll be adding this up and I'll be seeing that okay, I have 10. Okay, so I'll just draw this also. So the optimal solution would be just one stop over here, and once the one stop is here, I'll make another stop here too, and this is my first stop, and this will be my second stop, and only 2 stops require, and by that the third stop before that itself, I'll be able to reach the destination. So what I'll see is that I have 10 liters of fuel here, and I've got 60 liters of fuel here. With the help of the 60 liters of fuel here, I have 60 liters of fuel. I reach this position. I have 40 liters of fuel here. So basically I have 10 plus 60, 70, and once I do the 70, I have 40 over here, and 40 is basically 70 plus 40 is 110. So I'll be able to cross this 100 meters of distance, because I only require 100 liters of fuel to reach this location. And while before itself going, I can see that once if I reach over here, I'll get 10 plus 60 70, and once I reach here, because I'm able to reach here, right? I'm able to reach over here because I have 60 liters of fuel here, and since I have 60 liters of fuel, basically 10 plus 60, I have 70 liters of fuel. I can also go to this place, I can also go to this place, I can also go to this place. Right? We are not deducting the fuel over here, because what we are just choosing right now, right? So once I reach over here, we are just choosing right now, so there's no need to deduct the fuel, because we'll just want to calculate the total amount of fuel that we'll be having. And if the total amount of fuel is less than the total amount of fuel that is required, we'll be able to solve the problem and just give the number of stops, minimum number of stops, because ultimately we don't have to give the minimum number of fuel that is required, right? Or the fuel that is available in the tank afterwards. We don't require that. We just want to give the minimum number of stops. So this is what our approach would be, and we will be using a priority queue to do so. So what we will be doing is, once we have seen all the reachable stations, right? Once we have reached all the reachable stations, to get the maximum amount of fuel within that station, we'll be using the priority queue to do that. Now, moving on to the coding aspect, I'm pretty sure you might not be clear at the moment with the explanation, but once the coding part you see that, you will definitely be clear as to what we are trying to do. So let me see the total number of stations. This is the total number of stations. Basically would be the stations dot size. Okay, and now over here we have available fuel. Available fuel is basically the start fuel. That is the available fuel, right? That's the available fuel, and total number of stations is the stations, and the current station is 0. Current station is 0. Okay, so I'll be adding whatever variables that will be required as in go when we write the code. So while the the available fuel is less, available fuel is less than the target, right? Because we need the available fuel to be more than the target. Once we do that, we'll be able to return the number of stops that we have, right? So that also we'll have to calculate the total number of stops. Right now is 0. This number is 0. So now while the available fuel is less than 0, I want to see, with the help of the available fuel, how many stations I can reach, and I will choose the station with the highest fuel, and that is what the greedy approach is all about. So for that, what I'll be doing is, I'll be also have to declare a priority queue. We'll be declaring a max heap over here. So priority queue, which will be having a type of int. We do not have to declare other parameters, because the default parameter is what will be default priority queue, which is the max heap, is what we'll be using. So this is declaring the max heap. So now what we'll be doing is while the current station is less than the total number of stations, that is what we'll be checking. Total number of stations, right? Of course the variable should be better in the while we are actually coding it, but since I want to explain you, I'm just writing better a little longer forms of the variables, longer names of the variables. So the current station, while the current station is less than the total number of station, and the stations, the position of the station, right? So that will be also the current station is, this is the what current station is. And as we just know, right, so it will have two parameters, because the first parameter over here, and it will be saying the position, and the second parameter is fuel. So the station's position, that's the first one, right, we have to write here, is less than or equal to the available fuel. So that only those stations will be able to reach, right? Because if the available fuel is not permitting, then we'll not be able to go to the station. So only if the position of the current station is less than or equal to, even if it's equal to, it's fine, the available fuel. I'll just copy this and paste it for saving time. We can say current station plus plus. Current station is, you can just say that we are able to surpass that station. Current station plus plus, current station plus plus, and we will add that station. Before doing the plus plus, we'll have to add that into the priority queue. We'll add that, push that station to the priority queue, because why are we pushing it to the priority queue? Because we want the station with the highest amount of fuel within that, right? So we'll be pushing the fuel of that current station within the priority queue. So current station current station fuel is basically the first, right, the first element, because the 0th element is the position and the first one is the fuel. So that is what will be over here. So yeah, while that is the current station. So now if the priority queue is empty, if the priority queue is empty, that means we are not able to reach, we were not able to reach any stations with the available fuel, and we'll have to return -1. If it was not empty, that means we've reached some station. What we will do is, in the available fuel, we will just pick, I'll just paste it, so there is no error. I'll just paste this available fuel. We'll just add the fuel that was maximum in the stations that we have crossed. So available fuel plus pq.top, and we can say stop plus plus, and then we can pop that, because we visited that station, so we can pop that from the priority queue, and that's it. We can just, once the loop is over, we can return the number of stops, and that's it. I think we are good, because over here with the help of the available fuel, and then we are choosing over here, I'll just write the comment, we are choosing the station that we were able to pass, that has the highest the highest fuel amount. We're not directing it, because we're only calculating the available fuel to be more than the target. If this condition is passed, that available fuel is more than the target, that means we are able to find, we are able to reach the target. And with the help of the choosing part, we are just adding the number of stops. So because we are just solving the problem that minimum number of stops what is required, that's the reason we're not subtracting anything. And let's run this. I hope no errors are there. Current station, of course there is. Current station. Okay, I'll just copy paste this. We've got current domain, current station. Again we've got, okay, current station is equal to 0, which is fine. Stations is also fine. Total number of stations less than or equal to available fuel. Stations is a vector of vector. What can the issue be? The current station. Okay, pq dot push. Okay, over here the error is over here, just some naming error because I'm habituated of autocomplete. Current station is not a vector. Oh yes, actually this is wrong. This has to be stations, and current station is just one parameter, and then the fuel that we are pushing is the other parameter. So this has to be right, my bad. And then current station plus plus. I have to paste this over here. Stops plus plus, it's not stop. So देखिए, these are the mistakes, naming convention mistakes that are stopping the compiler. The logic is perfect. See, as you can see, we are accepted, and if we submit this also, we'll be able to get an accepted answer, and it beats 100%. Perfect. The time complexity of this is O of n log n. The reason, because we are just okay, don't get confused if we have two nested while loops, right? So it'll be of O of n square, because we are only reaching one station only once, right? Because we are having the current station as a global variable, and we are incrementing that, so we'll never be returning a previous station again. So since we will be never be returning a previous station again, only once, so these two while loops will only be traversing the whole loop once, hence the reason O of n. And since we are pushing this particular element within the priority queue, it takes log n of time, so that's the reason it is taking n log n of time. So that is the reason for this, and this is the most optimized solution to solve the problem. Okay, because we'll have to be reaching this particular station at least once, right? So we do have a lower bound of O of n, because we need to reach every station at least once, and since we need to also sort this part, so instead of using in log n, we are using a log n one. So this is the most optimized solution, and we cannot optimize this further. And thank you so much for watching, and please subscribe. Yeah, thank you.